Welcome back everybody, and in today's video I'm going to go over the exact values of trig functions. I'm just going to teach you two very simple methods in order to remember them. Let's get started. Okay, so method one is what I call the radical method. We are simply going to write a series of expressions that we can just simplify to these exact values. All you have to do is just remember to write their degrees or radians starting from 0 to 90. Okay, so I've already put those down for you. So if you just can remember this first starting point, root 0 over 2. Now, bear with me with this one. Just increase the value under the square root by 1 every time, okay, and keeping 2 on the denominator. Okay, now all we have to do now is simplify each one of those expressions. So root 2 over 2 is 0. This is just going to be root 1 over 2, which is a half. Root 2 over 2, I'm just going to leave it as root 2 over 2. Root 3 over 2, I'm going to also leave as that. And root 4 is 2, so 2 over 2 is 1.
No way. No way. Yes way!
Now, all you have to do is now just repeat those same numbers, but going backwards. So we're going to start with 1, but start up here with 1. So we're going to go 1. And then root 3 over 2, and then 1 over root 2, half, and 0. And now we have found all the exact values for sine and cos. For tan, I just want you to remember this one expression that it is sine over cos, right? So sine theta over cos theta is equal to tan theta. So if you have found sine and cos, you can just find tan just through that approach. So if we could just go over to here, sine over cos would be 0 over 1. Well, anything divided by 0 divided by 1 is 0. Okay, here it's a half divided by this. I'm going to turn this expression upside down and multiply. So that would just become 1 over root 3. And repeating that process of turning the second fraction upside down and multiplying, I will end up with root 2 over root 2, which is just 1. And finally, this one here, root 3. If we do sine over cos here, then we will have something over 0, which is undefined. So that will just be undefined. And there we go. Method 2 is the triangular method. Slightly different approach here. If we had a 60-degree triangle, okay, so that's pi over 3, we can split that triangle in half. Now, this is an equilateral triangle, so therefore then that this would be 30 degrees and this would be 90. The triangle, it has sides 2, and because I've cut that in half, that will be 1. Now all I need you to do is do this one thing for me, is find the side here that I'm just indicating in pink. Using Pythagoras, this is root 3. Okay, so a squared plus b squared equals c squared. We get that as root 3. Now what we can do is we can find all the exact values for 30 and 60. Let me just show you one example here. Let's say I want to know what sine 30 is. Okay, so remember 30 degrees is pi over 6. That is opposite over hypotenuse. So if we go up to here and we just focus on the 30 degrees, okay, then opposite over hypotenuse will be 1 over 2. So I'm saying sine of 30 is a half, which is correct. But let me give you another example. Let's say I wanted to know what tan 60 is, for example. Okay, so we go up to this same triangle up here and we focus on 60. Let's use a slightly different color here, blue. Okay, let's focus on 60. Well, the relationship for tan is opposite over adjacent. Okay, so opposite over adjacent. So looking up at the triangle, opposite is root 3 and the adjacent is 1. Okay, so that's root 3 over 1, which is root 3. And that is tan 60. Okay, so you can find all your 30s and 60s for all trig functions using that little triangle on the left there. So what about 45? Well, if we go and draw one more triangle and we say that this is side 1, this is side 1, using Pythagoras, you'll find that this is root 2, and this side is 45 degrees. Remember, that's pi over 4. Okay, so I'll just do one example here. What about if I wanted to find sine, right? Sine 45. Well, sine 45, remember the relationship for sine is opposite over hypotenuse. Well, using the 45 degrees here, we do opposite over hypotenuse, which is 1 over root 2. and that is our sine, and we can use that 45 degrees for any single trig function, sine, cos or tan, and there we go. We have all our angles for 30, 60 and 45. So the only ones that you would need to remember there are 0 and 90. So I'll leave that one up to you, but thank you for watching. Let me know how you get on in the comments below. Don't forget to like and subscribe to the channel. See you next time.